Hello student, welcome to my channel MEP Tutorials where we are learning the MEP related topic, that is HVAC, electrical, plumbing and firefighting. So our today topic is the plumbing related topic, and that is estimated water requirement, or you can say water demand calculation for the residential tower as well as the office building. So how to calculate the water demand for residential and the office building? So here I have taken one Excel sheet. You will get this Excel sheet in a link. So by that you can easily calculate the estimated water requirement or the water demand for residential as well as the commercial tower. So here in the residential tower, I will assume that number of flat is the 150 flat. So here I will mention the 150 flat. Number of person, I have taken here the 5% per flat because the parents, couples and the children's is there. So average I have taken here 5%. So here I will calculate the total number, and that will be 150 multiplied by 5. So this is 750 persons on in the total residential tower is there. The same I'll mention here also. Here I have mentioned the imperial units, and here I will mention the metric unit because some student requires the imperial unit and some student requires the metric unit. So I will mention here both unit. The imperial unit is also called as a British unit, whereas the metric unit is also called as SI unit, that is the international standard unit. So I will calculate the water demand or the water consumption calculation in a both way. So number of person is a 750. Now let's talk about the per capita per day requirement. The per capita per day requirement is the actual requirement of water in a per day by per person. If a single person requirement, I need to calculate the single person requirement for the entire day. So there is the another Excel sheet I have mentioned here, which is called as a water consumption per person per day at the residential area. If a single person drinking the water, that will be the 5 liter, and if he is cooking, so that will be the 10 liter. For the bathing, there will be the 1 bucket, and that is 1 bucket is equal to 20 liter. If it is toilet flushing, that will be the 25 liter. The average toilet flushing by per person is a 25 liter. The huge amount of water is always wasting in a toilet flushing, so that's why I have taken here as a 25 liter. Floor washing, I'll assume as a 15 liter. For cloth washing, or if there is a washing machine, the fully automatic or semi-automatic washing machine, there will be the 30 liter water is uses. If it is a kitchen sink or the utensils, that will be the 20 liter of water or the 25 liter of water we are generally using. Buffer uses, or I will say the safety factor, that will be the 10 liter. So the total consumption in a liter per person is a 140 liter. The same liter I will mention here in a liter section in a metric. So in a liter, this will be the 140. So 140 liter per capita per day requirement is there. Now I will convert this into the gallon. So for conversion of the gallon is equal to 140 divided by 3.78, because 1 gallon is equal to 3.78 liter. So if 140 liter is there, so gallon, if I am talking about the gallon, that will be the 37 gallon is there. Hours per day uses means in a total, in a 24 hours, I will take as a 15 hours. The total consumption hours is a 15. I have considered here as a 15 hours. So I'll mention here 15. So by easily I will calculate the daily consumption by per capita per day into number of person. So that will be number of person is a 750 multiplied by per capita per day requirement of water. So that will be 27,778 gallon. The same calculation or the same formula I will mention here, that will be 750 person multiplied by 140 liter. So that will be 1,05,000 liter, and this is the daily consumption of water in the residential tower. If I'm talking about the total volume, the volume is always calculating in a cubic feet and also in a cubic meter. So if I want to convert this total gallon into the cubic feet, that will be is equal to divide by 7.48, because 1 cubic feet is equal to 7.48 gallon. So that's why I have directly divided by 7.48. Same here for the cubic meter, this total liter divided by 1000, because 1 cubic meter is equal to 1000 liter. So I have converted this total volume into the cubic feet as well as in a cubic meter. Now let's calculate the average flow rate. This average flow rate is nothing but the requirement of water for the OH tank as well as the UG tank. Now how to calculate the flow rate? So flow rate will be definitely calculated by is equal to the daily consumption divided by the hour per day uses divided by 60, because 1 hour is equal to 60 minutes and I want this average flow rate in a minute. So that's why total consumption, total daily consumption divided by hours per day uses divided by 60. So that will be 31 GPM, 31 gallon per minute. Same here I will mention is equal to total liter, that is the daily consumption, divided by hours divided by 60. So that will be 117 liter per minute, and 1 GPM is equal to 3.78. Okay, so let's talk about the peak flow rate. So peak flow rate is always 300% more than the average flow rate, because peak flow rate is always using the more water. For example, at the morning the peak flow rate is the highest uses amount of water at the morning. So here I will mention is equal to 31 multiplied by 3, so that will be 92.59. So if I want to make it round up, just put the formula, so that will be 93 GPM. So if this is 93 GPM, this will be is equal to the same formula I will mention here, that is equal to 117 multiplied by 3, so 350 liter per minute. This is the peak flow rate of your water at the peak level at the morning time. So this is how I have calculated the residential tower water demand for the entire residential tower. Here I have taken the 150, that is the total flats. Then I have calculated with the 5, that is a 5% per flat. So 150 multiplied by 5. Then per capita per day, that is a 140 liter, and I have directly converted into the gallon, because 1 gallon is equal to 3.78 liter. So I have mentioned here the formula. Hours per day uses, that is a 15, I have taken here as a 15, and the daily consumption is number of person multiplied by per capita per day requirement is there. So here will be the daily consumption. The total volume is gallon divided by 7.48. Average flow rate, the average flow rate I have calculated, that is total gallon divided by 15 divided by 60. So this is the 31 GPM. Peak flow rate, this is the 300 times more, or I will say 3 times more, 300% more. So same calculation you have to mention in a liter also. You will get the liter as well as the total amount of water consumption, that is 1,05,000. Then you will get the cubic meter. This cubic meter is the tank capacity, the total volume of the tank, and average flow rate, that is the 117, whereas the peak flow rate is a 350. So here I have calculated the water requirement for the residential Let's talk about the office building. In the office building, same calculation, but there is some different types of calculation is available in the office building. Here we cannot multiply the number of office with the person. Here we need to calculate the total area of the office. Let us take an example that I have a, a 5000 square feet office area, 5000 square meter. So it is in a square meter, 5000 square meter office area. The total building is a 5000 square meter office area is there. It in this total area, I'll mention here, and if I want to mention in a square feet, so that will be 5000 multiplied by 10.76, so that will be the 58,800 square feet area for that office. This is the total office building area. Number of person, I have given I have assumed that in a 1000 square feet there is the 15% is staying there. So if I want to calculate the number of person, this is my assumption that 1000 square feet is equal to 15%. So easily I will calculate this is equal to total, this is the total floor area divided by 1000 multiply by 15%. So 807% in the total area of the floor. It means if the area of the floor is 50,800, the entire office area is the 53,800. So the number of person will be 807. Same here, if 5000 square meter is the total area, so I'll mention here the same. I'll mention here 807. This is the total person, the same total person I have mentioned also here. Let's talk about per capita per day requirement. Here generally 75 liter per person is considering, and in a office building, when there is a office building, we always consider as a 75 liter per person per day requirement is there. So if I want to convert into the gallon, so that will be 75 divided by 3.78, so that will be 19.84. so let's make it round up. That will be in bracket comma 0, so the roundup will be 20 gallon. So if it is a 75 liter, it will be automatically converted into 20 gallon. Hours per day uses. Now here I need to consider about the hours per day uses. So I will mention here as a 9 hours, because the generally 9 hours we are consider for the office building. So here also I will mention 9 hours. So according to the number of person into the per capita per day uses requirement, I will also calculate the daily consumption, and that is the number of person is a 807 multiplied by per capita per day requirement is a 20 gallon, so that will be the 16,140. The same here I'll mention 807, that is the total number of persons multiplied by 75 liters, so 60,525 is the liter of the consumption, the daily consumption in a liter. So according to that I will calculate this divided by 7.48, that is the cubic feet, and here 60 divided by 1000, that is the cubic meter. According to the same average flow rate, as we have calculated here the average flow rate, that is the daily consumption, the total consumption divided by 15 divided by 60, the same here I will mention is equal to, it is the daily consumption 16,140 divided by hour, that is the hour per day uses divided by 60. So here it is 29.888. So I will round up this. That will be the 30 GPM. So here the average flow rate is the 30 GPM, and here 60 divided by 9 hours. Here I will mention the total daily consumption, that is 60,525 divided by 9 hours divided by 60. So that will be 112.08. Let's round up this also. And that will be 113 liter per minute. So I'll also calculate here the peak flow rate, that is the 3 times more. So 30 multiplied by 3, that is a 90 GPM, whereas peak flow rate for in a liter, 113 multiplied by 3, that is 339 liter per minute. So this is how to calculate the water consumption or the water calculation required for the residential tower as well as the commercial tower, that is the office building. So by this calculation we can easily calculate the tank capacity, and that is the tank volume, water volume of the tank. And if I take in the water volume of the tank, I will easily size the tank sizing also. In the next lecture I will explain you how to size the tank, that is the domestic tank, flushing tank, and the others tank, how to calculate the tank sizing. So here I have calculated the water demand for residential and office building. So if you like my video, please subscribe my channel, and please mention if you have any query, please give the comments, and please subscribe my channel and push the bell button icon so you will get the more topics on the MEP related course. Thank you very much.